Welcome back to DellyMaths Concepts. What we're looking at today is that we want to solve quadratic equations. Here we're going to be solving by way of factorization. And for the ones that have already been factorized, for example, like number one, like we got this in a factor form, we're going to just apply the zero product rule to it, because here it is that we have two factors that were multiplied to give zero. Based on the zero product rule, we can conclude that it's either x plus 1 that is a 0 or k minus 5 that is a 0. And the reason why we are doing this is because we're saying if we multiply two things and the result is a 0, then either one of these things or both of them are 0. So in this case, in solving this part first, we will subtract 1 from both sides. So this is suggesting that k is equal to -1. So if k is equal to -1, then we will get a 0. Also, if we add 5 to both sides here, it is suggesting that k is equal to 5. So here it is that we have two answers. K is equal to -1, as well as k is equal to +5. In number 2 here, all right, so here at number 2, what we do have is so at number 2, we have a plus 1 times a plus 2 is equal to 0. So it's either a plus 1 that is a 0, or we can say a plus 2 that is a 0. A plus 1 is 0. We subtract 1 from both sides. So a is equal to -1. And in the other case, we would subtract 2 from both sides so that this part becomes a 0. So a is equal to -2. So these are our two responses. All right. So a is equal to -1, a is equal to -2. All right, so let's take a look at number 3. It's either 4k plus 5 is a 0 or k plus 1 is equal to 0. And the reason for that is two things multiply to give 0. So the zero product rule would have endorsed that. In situation 1, we're going to subtract 5 from both sides. So what we're left with is 4k is equal to -5. Dividing both sides by 4 so that we could isolate this k here, we can conclude that k is equal to -5/4. And that's one of the response. In the other instance right here, k plus 1 is equal to 0. So all I'm going to do to get the k to be alone is to subtract 1 for both sides. So as you can see, this gives us a 0 right there. So k is equal to -1, and this would have been my second response. So k is equal to -5/4, k is equal to -1. Let's take a look at number 4. In number 4, the zero product rule, again, two things multiply to give us a 0. We're going to suggest that my first binomial, 2m plus 3 is equal to 0. And in the other instance, I can say 4m plus 3 is equal to 0. Let us solve this one right here. Let's take 3 from both sides. Rewriting this, I'll have 2m is equal to -3. To get the m by itself, m is multiplying to the 2, so I'm going to divide both sides by 2, so that the 2 would have cancelled, leaving m. So m is -3/2. Let's take a look at 4m plus 3 is equal to 0. Let us subtract 3 from both sides first. In rewriting this, what I'm left with is 4m is equal to -3. In order to get the m by itself right here, what I'm going to do is I'm going to divide both sides by 4. So m is equal to -3/4. And this is my second response. Let's take a look at question 5. For question 5, it says x squared minus 11x plus 19 is equal to negative 5. In order to solve our quadratic, one of the things that we have to do is to make sure that everything is equal to 0. So I'm going to rearrange this. So I'm going to add 5 to both sides of the equation. So what I'm left with is x squared minus 11x plus 24, and this is equal to 0. Remember that in solving our quadratic, we need it to be equal to 0 first. So now what I'm going to do is to factorize this. If depending on your knowledge of factorization, basically, let me just break this quickly. The two numbers that I need would be negative 8 and a negative 3 to take the place of negative 11. So in other words, then I'm getting negative 8, negative 3 to work for me right here. So basically, what we're looking at is in here, we have an x minus 8, and we have a x minus 3. Right? So when we factorize this, we end up with x minus 8, x minus 3. Now, as you can see, it's now in a factor form, right? And in our factor form here, what we're looking at is that it's either x minus 8, that is going to be a 0, or it's going to be an x minus 3, that is going to be a 0. In adding 8 to both sides here, x is equal to 8, and that's one answer. The second response, I'm going to add 3 to both sides. So x is equal to 3, and that's the second response. So our answers are as follows: x is equal to 8, x is equal to 3. For those of us who were not certain here what happened, I could just quickly show us. When you have x squared minus 8x minus 3x plus 24, if you want to know how we get those numbers, our AC is 24, and that's multiplying a, which is 1, times 24 to get 24. The factor pairs that I got are as follows: 8 and 3. They do multiply to give 24, but when you add them, you get 11, right? So that is how I pick these numbers. There are two negative numbers because when I add them, I need to get negative 11. And then I factorize these by grouping. So the common factor here is x. So if I divide x into x squared, I get x. X into negative 8x, I get negative 8. The common factor in this part is going to be negative 3. Negative 3 into negative 3x is x, and negative 3 into positive 24 is negative 8. Then I refactorize by taking out the common factor x minus 8. And in the other bracket, I get x minus 3. That is how we end up getting these as our factors there. So that's what really took place right there. Do is we're going to make sure that everything is equal to 0. So I have to subtract 5 from both sides. So basically, I'm looking at n squared plus 7n, and then this becomes positive 10, and this is equal to 0. A very quick factorization here is that what we'll have here is n plus 5 and n plus 2. Those are the two factors that would have satisfied this, right? So then we're simply going to say n plus 5 is equal to 0, or n plus 2 is equal to 0. And if we subtract 5 from both sides here, n is equal to negative 5. That's one answer. And we subtract 2 from both sides here, then n is equal to negative 2 for the second response. All right. So there it is. We would have answered those. All right. Let's go to number 7. Similar fashion here. What I want to do is make sure that I have a 0. Everything is equal to 0. So I'm going to have to subtract 6 from both sides. So I'm left with the 6n squared minus 18n. This will give me minus 24. And now it is equal to 0. So what I want to do is to normally because everything is divisible by 6, I could divide everything here by 6. So you could see if I divide everything by 6, I'm going to be left with n squared minus 3n minus 4. And this is equal to 0. And then this factorization here, as you could see, can be done quite easily here. All right. So if we should factorize this easily, we're looking at n squared with a minus 4n with a plus n minus 4, and this is equal to 0. If I should group these up, then taking out n, I'm going to have n minus 4, and then I'm just going to have here a positive 1, and then n minus 4 again equals 0. Let's take out the common factor, which is n minus 4. And in the other two brackets, I'm going to have n with a plus 1. This is all equal to 0. At this point in time, I'm going to simply apply my zero product rule, because it's either n minus 4 is a 0, or it is a n plus 1 that is a 0. Let us look at n minus 4. Let's add 4 to both sides. We're left with n is equal to 4, and that's one of our answers. Secondly, let us subtract 1 from both sides in order to get the n to be alone here. So n is equal to negative 1. And then this is my second response right there. Let's go to 7 and last. 8 and last, I should say. So number 8. So my last question here, I'm going to be adding 7 to both sides in order to have. So when I do that, I'm ensuring that everything is equated to 0. So we're looking at 7r squared minus 14r plus 7 equals 0. I'm going to divide everything throughout by 7 because it is possible. So I'm left with r squared minus 2r plus 1, and this is equal to 0. Basically now, what I'm going to do is to factorize this, right? So if you try to factorize this, what we're going to have here is that this is going to become r minus 1 into r minus 1. So this is basically a perfect square trinomial that we're looking at. And then, as you can see, we have equal roots here. The result of this is either r minus 1 that is equal to 0, or r minus 1 is still equal to 0. Adding 1 to both sides, r is equal to 1, or adding 1 to both sides, r is equal to 1. So here it is that we have our solution, right? Thank you for watching. See you next time.